Hi, I'm Mike Wilson, Senior Relay Applications Engineer for Megger Group. Today I want to cover testing a 27P element, that's an undervoltage element, on a SEL 751A. This can also be used on a cell 351, 351S, 351A, 451, and so on and so on. Pretty much any SEL relay that has voltage inputs. So let's sit back and get started. We'll begin by opening Accelerated Quickset and navigating to Group 1, Set 1, Undervoltage element settings. As you can see here, we have a 27P1P with undervoltage trip 1 pickup that is a multiple of the V nominal, and right now that's 0.8 times V nominal. We can find our V nominal by navigating over to the Group 1 main settings, and we see our V nominal is line voltage, nominal line to line volts, and that's 120 volts. So put that in your notes because we are going to divide that by the square root of 3 to get a V nominal, a line to neutral voltage that we can use for our test set. That line to neutral voltage should be 69.28 volts. So when we get over to our undervoltage element, we'll see that that's 0.8 times 69.28, giving us a 55.43 VAC value for our undervoltage. Now that we have our undervoltage pickup values, we'll open up PowerDB Lite and navigate to the Relay Test Management Software, RTMS. We'll start by opening up a new file and then going to select New Test. Under Select New Test, we're going to pick a standard ramp. Now, under the standard ramp, the first thing that we see is the Channel 2 ramp. We have right now current amplitude. We want to deselect or unselect current amplitude, and we're looking for a voltage amplitude because of the undervoltage element that we're testing. As we can see under right here, we have it selected as perform pulse ramp. However, with an undervoltage element or an overvoltage element, we typically want to use a stair ramp. So we'll go up here to perform stair ramp. Next, we're going to configure multiple ramps. We're going to test the 27P element on A phase, B phase, and C phase windings of the relay. So under set number of ramps, we're going to select 3, which was already pre-selected, but that's how you do that. And then we see that this is the first ramp. Now under the first ramp, we should see V1. And I'm going to go ahead and deselect these current channels because we're just going to be using voltage channels today. We're going to enable all 3 voltage channels, and that's going to cover all of our tests, ramp 1, ramp 2, and ramp 3. However, under ramp 1, we're going to have voltage 1. Under ramp 2, we're going to change this to voltage amplitude, and that's just going to be voltage 2, channel 2. And then under ramp 3, we're going to change that to voltage amplitude, and that is simply going to ramp the voltage, the third channel, the third voltage channel. And if we go back to our notes, and I'll go back to ramp number 1. If we go back to our notes, we'll see that we had a nominal line to neutral voltage of 69.28, but a 27 pickup, an undervoltage pickup value of 80% of that nominal. That gives us a 55.43 value. So over here at expected, we're going to select expected and put in 55.43 3. And because we're testing an undervoltage element, we typically want to go from an unasserted or a deasserted state to an asserted state. So, of course, with the undervoltage element, we would be asserted if we started at 93%. What we're going to do is we're going to swap these values around as such. And I like to start with plus and minus 7%. So starting at 107% and not to exceed 93%. I have a 1 second pre-fault time. That'll give us an opportunity to clear up any undervoltage condition that may already exist because the test set isn't running. We'll keep the 15 cycle dwell time and the 0.1 volt, 1/10 of a volt resolution. Now we'll move over to ramp number 2. We'll do the same thing. We're going to move this to a stair ramp. Move this to 107, begin at 107 to end at 93%. Expected is the 55.43 volts. Keeping the same parameters there. And then we'll go over to ramp number 3. We see that did change over to channel 3. We're going to change that to stair ramp. Again, 107% for a start value, pre-fault for 1 second, to end at 90, not to exceed 93% of the expected value. And expected value is 55.43. Now, we should be ready to begin we'll be ready to begin the test as soon as we set our output, our spare output on the SEL relay to 27P or 27P1P, some variation of that. We'll go back to Accelerator Quickset and open up the hyperterminal. In the hyperterminal, we'll navigate to level 2 access and run the set space L space out 102 turns command. And we'll put in 27P1 as our element and run the end command. Save changes. And now we're ready to begin testing. Now we head back over to our relay test management software and we are ready to run the test. So we'll go here to play the test. See the voltage on channel 1 is decreasing, starting off at 107% of the expected, and looks like we ended around 55.3. It's going into channel 2 now for the B winding. Now, if you want to improve the accuracy on these, you would adjust the resolution from 0.1 volt to, say, 0.05. Now that we've finished the test, we'll X out of this and go up to report, view report. And we see that we have our 27P, 27PB, PA, PB, and PC. Of course, these are all changeable. These are all editable. So you can change this to whatever you like, 27P, pickup, test, etc. You can put in all of your substation and nameplate information and so on. Then we'll accept. go to last screen. So that's how you test a 27P undervoltage element using SMRT46 Delta with PowerDB RTMS software, relay test management software. And again, we were using a cell 751A as an example, but of course this same routine is translatable to a cell 351, 351S, 451, 551, you name it. Any of the cell relays with voltage inputs. The basic concept is that you're ramping the voltage from a higher value to a lower value. If you have any questions or comments, please post them below, and we'll see you next time. Thanks.